Okay, so question number 10. This diagram shows two particles, P and Q, which lie on the line of greatest slope of plane ABC. So here they are lying. Particles P and Q are each of mass m kg. These both are of same mass. Plane is inclined at an angle theta to the horizontal, where sine theta is 0.6. So we need to just understand this, that sine theta is given to be 0.6. Then we have the length of AB is 0.75. So this is given to be this much is 0.75. And BC length is given to be 3.25. The section AB of the plane is smooth and the section BC is rough. So this part is smooth. And this one is rough. So what will be the difference? Difference will be that there will be a coefficient of friction, like the resistance between in this part. So there will be a coefficient of friction. So that coefficient of friction is 0.25. Particle P is released from rest at A, and at the same instant the particle Q is released from rest at B. So this means the initial velocity at P is 0 and initial velocity of Q is also 0. Now what we need to prove is that particle P reaches B. Means when it is released, it reaches at this point, P is here, with a speed 0.5 seconds after it is released. Its speed is 3 meters per second. That means the time it took for particle P to reach point B is 0.5 seconds, and the velocity of P is 3 meters per second. So these are the information that is given, and this is what we need to prove the time and the velocity. So first of all, let's resolve our component, our weight component. So this is your mg for particle P, and this would be for your particle Q. If we could write them in the middle would be more like this and like this. Okay, not very precise, but it's fine. So this is your mg, this is your mg. Now we have to resolve it. Goes the same in this way. Okay, so there is one error in this. This will be along the plane, perpendicular to the plane and then parallel to the plane. So it must be like this, and this one is in this way, so like this. Okay, so now the direction would be this way and this way. The angles in the center would be theta, so this will become mg cos theta, and this will become mg sin theta. Same goes here. It is this way and this way. So mg cos theta and mg sin theta. Okay, now, so what are the things that are given to us to find out the time? We need to find time. First thing that we need to find is time and velocity of p. So, and what is given to us in the initial velocity of p is 0. Secondly, the distance it must have covered is 0.75 meters. Okay. If we need to apply any equation of motion, so the thing that we must be needing would be acceleration. And acceleration is that what we don't know. So if a body is released from P, so it is moving under the action of its gravity, so it must be having some acceleration. To find out this acceleration, first of all, let's apply the forward forces minus backward forces equals to ma. So what is forward? What is the force that is making it move forward? That is mg sine theta. Okay, is there any backward force? No, because the surface is smooth, so no friction and no other backward force. So mg sine theta minus 0 equals to m times a. Sine theta is given to be 0.6, so mg 0.6 equals ma. M and M are going to be cancelled out, and we are left with A to be equals to 6 meter per second square. Now, when we have this, now we can apply the equations of motion. If we are dealing with S and we have initial velocity also, so can we use this S equals to ut plus half at square to find out t? Okay, 0.75 equals 0 times t plus half. 6 times t square equals 3t squared equals 0.75. And then t square would be equals to 0.75 over 3. So time from this we will get to be root of 0.25, and that would be 0.5 seconds. So this is the first thing that we needed to prove, and we have proved it. The time particle reaches P 0.5 seconds later. Okay, now these are the set of formulas that we have used so far. Lastly, to find out velocity, we can use v equals to u plus at, because we know initial velocity, acceleration, and now we also know the time. So v will be equals to 0 plus 6 times 0.5, and that is 3 meter per second. So this is the second thing we have proved, that velocity of particle P is 3 meter per second. So that's all about part A. Now let's do part. Okay, so part B is this. Now find the time it takes from the instant the two particles are released until they collide. So if we understand the scenario, not going back, this was particle P, this was particle Q, this was released from rest, and this was, so it's this was also released from rest. So at some point here, if the velocity of this is more than this velocity, then they are going to collide at some point. So we need to find that point, the instant at which they collided. Okay, so we have so far found the velocity and acceleration of particle P. We know velocity of P we found to be 3 and velocity acceleration we found to be 6. Okay, for particle P. Now let's find out for the particle Q as well. Okay, for particle Q, first find the acceleration. Okay, so again for acceleration we will be using forward minus backward equals ma. So but we need to look into this, that in this specific case we have more to understand because the surface is now rough from B to C. So if this is the forward force, there must be some backward force as well, that would be mu r. Okay, and have they told us what is going to be your, also there would be, what would be r? R would be, you can find r by equating the up and down forces, and because there is no net movement in the vertical direction, so the two forces will equate. So r will be equals to mg cos theta. Okay, and we know we found sine theta to be 0.6. Sine theta is 0.6. So theta would be sine inverse of sine inverse of 0.6. So instead of solving it, just put this theta over here. So m is mg, we know to be used to be 10. So cos of sine inverse of 0.6. So this will give you mg times 0.8. And this will give you 0.8 times 10 would be 8m. Okay, so your r is here to be 8m now. So let's apply the forward minus backwards. So forward forces mg sine theta and backwards is minus mu r. So apply this. Mg sine theta minus mu r equals ma. So mg 0.6 minus 0.25 times 8m equals ma. M, we can take it to be common, so it will become 6 minus 2 equals ma. M and m will be cancelled, and we get acceleration to be equals to 4 meter per second squared. Okay, this is for particle Q, the acceleration. Now we found acceleration, now we also need the velocity. Okay, so velocity, for the velocity as well, we will be using the same u plus at. Okay, what is this velocity? Velocity at the instant after it is released, 0.5 seconds after it is released, as we found for the particle P, 0.5 seconds after released from rest. From rest. So it would be, initial velocity for Q was also 0. 0 plus 4 times 0.5. So it would be 2 meter per second. Okay, so this is like what we needed so far. Now to understand the scenario and what we need to find, let's look into the question. Like, find the time that it takes from the instant the two particles are released until they collide. So as far as we just found it, what we have found so far is that this particle P is here and Q is somewhere here after 0.5 seconds. So we found what is the velocity of particle P and what is the velocity of particle Q. Now we have to understand how can we find out the time during which they will collide. Okay, 0.5 seconds have already passed. Now how much more time will be passed, then they will collide. So to find out that time, there are two ways to do that. There is one way that you find the relative velocities of both, because you know one velocity and the other. So if you find the relative velocities and then you divide it with the distance, what it is, s equals to v times t. So if you find the relative velocities and we divide distance by relative velocity, we will get the time. How much distance is left, we should also be finding that. This is one way of doing it, but in this particular case, there is a case of acceleration as well. So the better way to do would be that if you make an equation out of it. So let's make an equation. How much distance would it be in between them? If the particle Q is here, particle P is here, particle Q is here. So how much distance is in between them? Can we find out how much distance is between them? If we could figure out how much distance is between them, then we can use that to make an equation. So when this particle was P was here and Q was here, it has moved some distance in 0.5 seconds. So we can use your distance formula, like the formula that you use for distance in equations of motion, s equals to ut plus half at square, to find out in these 0.5 seconds how much distance it has covered. So this will be the distance between these two particles. So let's find it out. S equals to ut plus half at square. This is for particle Q. Okay, so it would be initial velocity for Q was 0, half acceleration we found to be 4 times 0.5 square. So here we can also write 0.5, but eventually it will be 0. So after solving this out, we will get it to be 0.5 meter. Now, if we found to be the distance between them is 0.5, so that means the distance that P will cover will be equals to the distance Q will cover plus 0.5. Now I make you understand this statement again. Now, for instance, here they are going to collide. So the distance this SP will cover after here, like after covering 0.75 meters that we have discussed previously. Now we are talking about when they are passing from point B onwards. So the distance P will cover will be equals to 0.5 meters more than SQ. Q will be moved from here to here. For example, it moves X distance. Then P will move X plus the distance. It will already the Q will move. Okay, so SP will be equals to XSQ plus 0.5. this SQ will just move from here to here, so that we call it to be SQ, but P is going to move 0.5 meters more than that. So this is how we made an expression out of it. When we will be substituting our values into this expression, we will be getting your final time that is needed to cover this distance. Okay, so SP will be equals to SP is the same UT plus half AT square. We will substitute in the values later on. So it is UT plus half AT square equals U of P Q T plus half AT square plus 0.5. So what is the initial velocity of P? Now we are starting from point B. From point B onwards, we are considering that journey. So at that point, initial velocity of P, we take it to be the velocity of P, and that was 3. So 3t plus half what was the acceleration of particle P? 6. Okay, so 6 times t square equals, what is the initial velocity of Q? At point B, it was 2t plus half 4 times t square plus 0.5. Okay, now 3t plus 3t square equals 2t plus 2t square plus 0.5. So now let's find out time out of this. So 3t square minus 2t square plus 3t minus 2t minus 0.5 equals 0. Okay, one more thing to understand is, now this surface that we are taking into consideration after B, like from B to C, this surface is not going to be now the smooth surface, it is a rough surface. Okay, so the acceleration would be the same that we have found for the particle Q. So even for the particle P, the acceleration we take it to be 4 because the surface is now rough. Okay, so we'll take that into account. So here it would be then 2t square. So there will be both sides 2t square, so they will be cancelled out. So don't write this out. This is going to be 2t square and 2t square, so these both will be cancelled out on both sides. So we are left with 3t minus 2t equals 0.5. So t will be equals to 0.5. So this is the time that is taken by now the two particles to collide. So initially, but they are not asking you just this time, they are asking you from the instant two particles are released. So initially for the particle P to reach this point, point B was 0.5 seconds, and particle Q in this time was here somewhere in between. So this was 0.5 seconds. And now to cover this distance between them, we need what time was taken. We found that, and that is also 0.5 seconds. So the total time taken by both of them is, so the total time is equals to 0.5 seconds plus 0.5 seconds. So this will add up to 1 second. So this is the total time taken by it to from the start to when they collided. Okay, so the most important thing was in this whole calculation was this point, that we are going to take not the acceleration of p, because the surface is rough, so we will take the same acceleration that we took for particle q. Okay, so we will take this to be acceleration of particle q. So this is how we end up doing this part B as well. I hope you get this. Now let's do part C. Okay, so now the two particles coalesce when they collide. The coefficient of friction between the combined particle and the plane is still 0.25. Find the time it takes from the instant the particles collide until the combined particle reaches the point C. Now we need to find the time during which it reaches the point C. Okay, so to find out this, we actually need to find how much distance SQ has already covered, like from here to here, how much distance it has covered out of 3.25 and how much is still needed to be covered. Okay, so it was released, so initially it has covered 0.5 meters. No, in 0.5 seconds initially it has covered 0.5 meters. Now we need to find, this is we already have found. Now we need to find what further distance it has covered. Again, the further 0.5 seconds. So again apply S equals to UT plus half AT square. So for next 0.5 seconds, distance covered, we need to find that. Distance covered is given by S equals UT plus half AT square. So now the initial speed of particle Q was 2 meter per second. Time we need to find, time is 0.5 seconds again. Okay, and then half, acceleration is 4 and 0.5 square. Okay, so this will give you to be 1.5 meters. So initially it has covered some distance. Okay, that was 0.5 meters, this distance. Initially this distance has covered 0.5 meters and now it has covered as 1.5 meters. So how much distance is left? Distance left to be covered to reach C, left to be covered to reach C will be total 3.25 minus 1.5 minus 0.5. So it is 1.25 meters needs to be covered now. Okay, so but there is a thing that now they have coalesced, so we can use the collision of particles now to understand their velocities. Okay, for this reason we need three velocities. velocity of P before collision, okay, before collision, the particle P velocity. The 2 and 3 velocities that we found are previously when they pass through point, like for the particle P when it is passing through point P, and for particle Q its velocity was when it has moved 0.5 meters. It is ahead of 0.5 meters from the P. But now the velocities that we need to find is before the collision, just before colliding. What is the velocity of P? What is the velocity of Q? And what is the combined velocity of P plus Q after collision? Okay, we need to find this out. So for the first one, Vp equals to Up plus At. Obviously, we are taking this to be as Vp because this we had some initial velocity as well. So now just before colliding, we are taking it to be Vp. And initially the velocity of P was 3, okay, and the velocity of Q was 2. So 3 plus 4. We are taking acceleration to be 4 everywhere because now the surface is rough for this after point P. To see the surface is rough, and the velocity of Q will be, initially it was 2 plus 4 times time is 0.5 seconds, which it took before collision. So UQ plus AT. So this will add up to give you the velocity of P to be 5 meter per second and velocity of Q to be 4 meter per second. Okay, so here I can write it 5 and 4. Now, using conservation of momentum, by conservation of momentum, M1 MPUP plus MQUQ equals to MP plus MQ times V, because now their velocity will be combined. Okay, now they coalesced. So the masses of both were same, so M times 5 plus M times 4 is equals to M plus M times V that we need to find. So 9M equals 2mVpq. So N and M will be cancelled out. We are left with velocity of coalesced particle to be 9/2 meter per second. So this would be 9/2 meter per second. Okay, so we found all the velocities, and now we will be using how much this we need to find the time to reach C. So this will be, we can use the distance form, again the equation of motion involving the distance and time. So S equals to UT plus half AT square. So now the particle is coalesced. So this is actually the velocity of PQ, and time we need to find, and acceleration again we will take to be 4 because the surface is rough, and the distance covered is the 1.25 that needs to be covered to reach C. So 1.25 equals 9/2 times T plus half 4 times T square. So this will give you 1.25 equals 4.5 T plus 2t square. Now solving this all to get the t value. So 2t square plus 4.5t minus 1.25 equals 0. Okay, to make it more simpler, we can multiply the whole equation by 4. So 8t square, to make it a whole number, 4.5 times 4 would be 18 t, and 1.25 times 4 would be 5. So let's see what will be their back. I think so this one is not needed. We can directly apply the quadratic formula. So let's apply that. T equals to minus b is here 4.5 plus minus b square is 4.5 square minus 4a is 2 and c is minus 1.25 over 2a. So this will give you, after calculating it in the calculator, this will directly give you two values of t, 0.25 and minus 2.5. So as obvious, like negative value for time is not accepted. So your final value for time would be 0.25 seconds. Okay, so this is the time it takes from the instant the particles collide until the combined particles reaches C. So this is your time for this whole journey. So this is your question number 7, and by ending this, we are also ending this paper, February March 2024. I hope you understand this question. Please, for any queries, any problems, any suggestions, comment us in the comment box. Thank you very much. Allah Hafiz.